Hey guys, I'm sorry I'm not there today. I am serving jury duty and I will hopefully be back tomorrow on Wednesday. So I have left this worksheet for you called heat of reaction. So there's a word for heat of reaction and that word is enthalpy. Now let me grab a screenshot of this so I can make some notes on this top part. So enthalpy means the heat of the reaction. Its symbol is delta H. Since it's got this little triangle delta, you know that means a change, just like when we did delta T. So a change in energy is called enthalpy. You guys hopefully read yesterday about endothermic and exothermic reactions. Endothermic reactions, there's a change in energy and that they use heat. They absorb heat from their surroundings. And exothermic reactions produce heat. So we say that it has a negative delta H. The way that we find this is we use something called the heat of formation. I'm sorry about that. Let me try that line again. Anyway, we use heat of formation, which is an H with a little f. And that's a way to tell how much energy is stored in a compound. Only compounds will have energy stored in them. And we will write that amount of energy here on the bottom. So in this example, you can see that this negative 877.3, that's the heat of formation for calcium chloride. It goes with that. And so they're all, you guys can hear that my cats are knocking things over because I'm making this video from my home this morning. One thing it does not say on this worksheet, but you will need to know, is that the heat of formation for an element is always 0. So if it's not a compound, if it's just an element with only one thing on the periodic table, the heat of formation will be 0. And we'll do an example that has some of that in just a minute. So we're going to take those heats of formation and we're going to subtract products minus reactants. So we're going to find the total for all of the products. These are the products after the arrow. And you can see that's what they're doing here. And notice that they're multiplying the coefficient times the heat of formation, like here. So those are the products, so they go first. So we kind of get this like crisscross thing happening. And then we subtract the reactants. So these are the reactants before the arrow. The heats of formation are being totaled up. Notice that it's always a good idea here to use lots of parentheses and brackets because weird things happen with negative signs. Okay, so feel free to look over that example and I will solve one more example, maybe two if we have time. So I'll do this next one with you. Grab that. All right, there we go. Number 1. So it says find the enthalpy. So I'm going to be finding the delta H, the change in energy. So I'm going to do products minus reactants. And it gives me only this piece of information. It says that the heat of formation for sodium chloride is negative 407.27 kilojoules per mole. So I know what this one is. It doesn't tell me anything about sodium and chlorine. Well, but I know that those are going to be 0 because these are elements, right? Sodium is just an element. It's only one thing on the periodic table. Same thing with Cl2. Both of those will have a heat of formation of 0. Okay, so let's do this. I'm going to I know you don't have this space on your paper. You're going to have to make it fit in this spot, but I'm going to kind of work it out down here. All right, so we're going to do products minus reactants. My products are here after the arrow, and I need to multiply by the coefficient. So Na has a coefficient of 2, so I'm going to do 2 times. Na is an element, so it's got a heat of formation of 0. Plus chlorine, also an element, also will have a heat of formation of 0. I'm going to put that in brackets. Minus the reactant here. So I've got a coefficient of 2. So I'm going to do 2 times this number that the question told me. negative 407.27. Okay, close my brackets. All right, products, finding that amount's going to be pretty easy because 2 times 0 is 0, plus 0 is 0. So my product side is just 0. Minus this, I'm going to plug into my calculator. 2 times negative. Oh, you know what? I think on this, and the way that you do negative signs are going to be different on every calculator you use. On this one, it looks like I have to type the number first and then hit that negative sign. So negative, I'm going to put this in parentheses again. $814.54. Okay. Now, you might be wondering, why did I mess with this side where the answer was going to be so obviously 0? And here's why. I'm going to plug this in my calculator just like I have it. 0 minus negative 814.4. Ta-da! Becomes positive 814.54. So we have to be very careful with signs in these kinds of questions. My units are going to be kilojoules. kJ for kilojoules, that's 1,000 joules. Okay. And it says for each box, write whether the reaction is endothermic or exothermic. If you look back at the top of your worksheet, it says exothermic reactions have a negative delta H. Endothermic reactions have a positive delta H. I sure ended up with a positive answer here. So this one's going to be endothermic, and you can abbreviate it just endo if you want to. Okay, I'm going to do a couple more examples. I'm going to put them in another video so that this one doesn't run too long. You might want to, if you're feeling confident, go ahead and try this next question before you watch the video to see if you can get it right. Good luck.